we're going to take a look at something called the exterior angle theorem. So first we want to talk about what is an exterior angle. So an exterior angle is when we extend one side of a triangle. So if I have a triangle, when I extend one side, it creates an exterior angle. All right. And then when we're using the word remote, we're talking about something that's far away. Okay. So the exterior angle theorem says that any exterior angle of a triangle has a measurement equal to the sum of the two remote interior angles. Okay. So in this picture, our exterior angle is angle 3 here. Okay. And our remote interior angles are angle 4 and angle 1. So they're the ones that are not adjacent to angle 3. So that means the measurement of angle 3 is going to be equal to the measurement of angle 4 plus the measurement of angle 1. Right? We are going to go ahead and do a little proof of this real quick. This is a short proof, shorter than our triangle angle sum theorem. So what we're going to start with in this proof is that we know we have a triangle and it's triangle ABC. That's our given. That's all we know. Okay. So because this is a triangle, we know that the measurement of all of its angles are equal to 180 degrees. So we're referencing this picture up above. So the measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 3 is equal to 180. So we know that because that is our triangle angle sum theorem, which we proved in an earlier video. Okay, now looking at this bottom here, we know that angle 2 and angle 3 are going to be supplementary. So we know that angle 2 and angle 3 are supplementary. And we know this because they are a linear pair. So that's definition of a linear pair. Okay, so if they are supplementary, then we know that their measurements, when we add them together, is equal to 180 degrees. That's our definition of supplementary. Okay, well, what can we do with this? Well, now I can do some substitution. Okay, if this is equal to 180 degrees, measurement of angle 2 plus measurement of angle 3, then I can substitute that in for 180 over here. So let's do that. I'm going to need a little bit of a smaller pen size. Okay, so the measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 3 is equal to, and instead of 180, I'm going to write the measurement of angle 2 plus the measurement of angle 3. So I'm allowed to do that because of the substitution property. Okay, well now what do I want to do? Well, I see that I have a measurement of angle 2 on both sides and a measurement of angle 3 on both sides. Okay, and I just realized I made a slight error in the beginning. This should have, not line 2 here, should have been, instead of an angle 3, this should have been the sum of our interior angles. So my apologies, that should have been an angle 4. Means down here, we need to get rid of that. That should be an angle 4. So that's because line 2, we should have been using the sum of the interior angles. And I made an assumption that that was 1, 2, and 3, but it's 1, 2, and 4. Okay, so with that in mind, now we have an angle 2 on either side. I'm going to subtract the measurement of angle 2. I can do that because it's just representing a number. So if I subtract the measurement of angle 2 from both sides, it's going to cancel out, right? Because it's just 0. So I'm going to be left with the measurement of angle 1 plus the measurement of angle 4 is equal to the measurement of angle 3, right? So really I just went in here and I said, all right, minus the measurement of angle 2 minus the measurement of angle 2. That cancels, and I'm allowed to do that because of the subtraction property of equality, saying that I can subtract the same thing from both sides. And now we have achieved exactly what we wanted, which is that the sum of those two remote interior angles is equal to the measurement of the exterior angle. So that's our proof, but let's go ahead and put this to use. Okay, so I'm just going to highlight the angles that we're working with here. So the remote angle is equal to the sum of the two, the exterior angle is equal to the sum of the two remote interior angles, all right? So we have that kind of set up there, but let's just set it up in an equation. So that means x plus 57 is going to equal 134. So we just take the sum of those two remote angles and set them equal to the exterior angle. So if we solve, we're going to find that x is equal to 77. So that would also be that degree measurement right in there. Okay, how can we apply this in a slightly more complex situation? So in this case, we have a slightly different setup. So you want to find your exterior angle, and then you want to find your two remote interior angles. So that's those guys right there. And you know that your exterior angle, 2x, is going to be equal to the sum of those two remote interiors. So that was 90 plus y plus 4. Well, I can't solve that yet because I don't know what y is, and I don't know what x is, and I can't have an equation with two variables. So what can we do first? What can we solve for first? Well, I can notice that we have a linear pair right here. So I'm going to use that to try to find y. So I know that y plus 4 plus 150 has to equal 180. All right, that's one thing that I know. Okay, so let's solve that. That tells me that y needs to equal, so we combine like terms, we get 154, subtract that from both sides, y needs to equal 26. All right, great. So now we can go and substitute that in. So y doesn't have to be y anymore. We said, oh good, that's 26. So that makes our life a little bit easier. So now let's go ahead and solve this. So we get 2x is equal to 90 plus 26 plus 4 is 120. Divide both sides by 2, we find that x is equal to 60. So if we wanted to substitute back in to find the degree measurement, we'd take 2 times 60, or we'd find that this is a 120 degree angle up there. So sometimes you might have two steps to find your end goal. You won't only be using this exterior angle theorem. Don't forget about your linear pairs and your interior angle sum theorem as well. Okay, so here we go. Again, exterior angle, two remote interior. But we have the same problem where we have two variables when we would set up this equation. So let's try to use something else to solve for one of them first. And I'm going to do the same thing where I'm going to recognize I have a linear pair here, and I'm going to make use of that. So I know that 2x plus 4 plus 118 needs to equal 180 degrees, okay? Or 2x plus 122 needs to equal 180. Subtract 122 from both sides. 2x needs to equal 58, or x needs to equal 29. So now if we substitute that back in, 2 times 29 plus 4, we're going to find that degree measurement, and then we can go ahead and use it in our equation. So 2 times 29 plus 4 is 62. All right, So now I can use my my exterior angle theorem to solve this problem. 122 is going to equal the sum of the two remote interior, y plus 62. Subtracting 62 from both sides, we're going to find that 60 equals y. And then that's our last piece if we want to define both of our variables. There are different ways to go about this. This one we could have actually used our triangle angle sum theorem as well. So you're going to find different approaches to these problems. But in general, our remote exterior angle theorem is or our exterior angle theorem is going to be pretty powerful in these situations.